The next one is string. Disk input unformatted or formatted, we can use the same function to access the string. That is fputs, fgets. Fputs to write a string to file. Fgets to read a string from file. Fputs, it's write a string to file. Fgets, it's read a string from file. By using fgets, fputs, we write and read a string to the text mode file. Main file star fp, character str of 60, it is a character array. A equal to y, a is a character variable, this just we assign y. Fp equal to fopen, file name is poem.txt. W, it is a write mode. We can write wt, both are same. W or wt, both are same. So because defaultly all mode is text, we put w. This is write mode of text, write mode in text format. If we put write wb only, it is a binary mode of write, that is binary format, write mode of binary format. So w or wt both are same. If we want to open a file in binary mode, just we put wb. So here we open the file in text mode only, that is poem.txt w. If the file is successfully opened, it return address of RAM memory address. It make a stream between hard disk and RAM memory. Then it return the address of that RAM memory. Then assign to FV. If failure, the file opening error, it due to any files opening security, network security, or file is not available. If it cause any error, it return null. The condition is null. Already we discussed it in previous program. In null, error opening file, terminate the program. If the successfully opened, the condition is false, then the while loop is executed. While a equal to y, that is a already consists of y. The value of a is y. So y equal to y. The condition is true. Gets of str. Gets is a console input to get string. Gets is a console input. So it get string from through keyboard from user. If you type data, if you we can type string. If we press enter key, up to the enter key, it get stored into the str. For example, here we type this string. It is the cursor is waiting at the time of execution. The cursor is wait to accept the string. Just we enter la lu le dot dot dot. This is a poem. That's why we put a dot 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 and exclamatory symbol, all thing. So la lu le. Then we enter. We press the enter key. It stored it into str. Store it into str. Str is a character array. So it can hold 60 characters. Here we give approximately 12 character. So it's stored that is str of 0, str of 1, str of 2, str of 3. So it's stored la lu le. This string stored into str. Here fputs. By using fputs function, file put string. The short form of file put string is fputs. Str fp. Str is a character array. That str is stored la lu le string. That is write into fp string. That is fp is a address of poem.txt. So la lu le, this string is write it into the poem.txt. Then display one message, add another y/n. So f plus of stdn a equal to get char. This is also console input to get character, get char. If we press y, so that y is assigned to a. If we press n, that n is assigned to a. But it display add another record. The cursors wait to get one character. What is the meaning of f plus of stdin? If we put two different, that is printf is a formatted console IO function. Printf is a formatted console IO function. Getchar is a unformatted console IO function. We already learned about the console IO in previous chapters. Printf is a formatted console output function. Getchar is a unformatted console IO function. We put two different, that is unformatted and formatted. That is printf is a formatted, getchar is a unformatted. So compiler assume it is a compiler error. It is a compiler error. So it take a previous input. If the loop, the first time loop, if we give a y, that y is assigned to a, then continue the loop. Next time also, if we press anything, it will not get any input. It take the previous input to the new input. That is, if you press yes the first time, the same input is it will not get new one. The loop is continuously execute. So we want to flush the memory, that is previous input. We want to flush the previous input from the memory. So this problem raised at the time of, if we put formatted and unformatted. The first formatted statement, immediately we put on unformatted. So this problem is raised. So to overcome the problem, we put f plus between formatted and unformatted. F plus of standard in. So then getchar, if we put y, add another y/n, the cursor is wait to get input for getchar y. If we press y, that y is assigned to a. The loop continue. While loop continue. So again a is y equal to y, the condition true. It gets another string, la 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 la, exclamatory symbol. So if we press enter, that string is stored in str. Already some data is available in str. It is overwrite by la 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 la, already available la lu le. The new string is la 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 la. That la 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 is overwrite. It is replaced. Then it write the new string into fp. The first already that file stored la lu le. Now la 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 is also stored in to the poem.txt. Then again it display the information, that is add another y/n. If we press n, so that n is stored in a, the loop continue. N equal to y, condition false, it come out the loop. Then close the file, f close of fp. So the stream is removed. The stream will remove from hard disk and RAM memory. So now we write some string to a file, because it is a unformatted text in string. In previous slide, we discuss about the character. We write a character and read character through file copy program. In this program, we get some poem, that is la lu le, la 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 la. We store it into the poem.txt. This is another program. Through this program, we read the data. So after the program execution, if we open the poem.txt file using any text editor, it may be a notepad or a wordpad or turbo C compiler. So the poem.txt contains these strings. This is a program to read the string. This program to write the string to file. This program for read a string from file. File star fp character str60 a equal to fp fopen file.txt r. Here we put w because we want to write a string to file. Here we want to read a string from file. So we use r. So we can also put rt. Defaultly r is a text mode. If we want to read a file and binary file, here we put rb. So here we access the text file. So here we just put r or rt. If fp equal to null, if a file opening error, it will return null. Then it compare, the condition is true, it error opening file, it terminate the program. If the file is open, it's not a file.txt, it is a poem.txt. This is also typing error. Poem.txt. This is a poem.txt. We open the poem.txt file in R mode. If it is open, the address is stored in fp. The condition is false. While of fgets of str, here we use fgets to read a string from file. Here we use fputs to write a string to file. This has 3 arguments. In this case, fputs we put only 2 arguments. First one is a string variable. The second one is a file pointer variable, file structure pointer variable. In fgets we use 3 arguments. The first one is a string variable name, the address of string or a string variable name. 60 is a total number of character, total number of maximum character. fp is a structure pointer variable. fp has the address of this file. So fgets str, 60, fp, it read a string. It read a string from fp and stored it into the str. It read a string from it read a string from a file poem.txt. This is a type error, poem.txt. It read a string from poem.txt, then it stored it into str. Here we use puts, we display the string of str. So what is the string at the time of first time? So it read a string of the first line. What is the first line? La lule. The la lule is read from fp, that stored into str. str is a character array, stored into str. Then we puts, the puts is also a console output for string, console output for string. So puts of str display the string in a new line. Puts of str. So what is the data of str? La lule, display la lule. Then the loop continue. Then it's get another record, another 60. So another is la 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 la, that's stored in str. So it return that address. So the condition is true. The address equal to null. The condition is return address. Here we want to put not equal to null, not equal to null, not equal to, we put exclamatory equal to null. This is also typing error, more typing error. Okay, not equal to null, exclamatory symbol not equal to, exclamatory symbol equal to not equal to null. The first time it says la lule, it returns some address, that address is not equal to null. Then it execute, it continue the loop, then it get another string la 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 la. This is also written some address. Instead that read string and stored it into str, then this function return address of the line. So it is also not equal to null. Here we must put not exclamatory symbol, not equal to null. So it's read another string, the condition is true, not equal to null. It displays that string la 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 la. Then it continue the loop. No data is there. So it's return null. Null not equal to null, condition false. It come out the loop. Here it is a typing error. We must put exclamatory symbol equal, that is not equal to. So read first line and stored it into str, it returns some address, that address is not equal to null, it display it, then continue the loop, it read next line, it returns some address, that address is not equal to null, it display that next line, then it return no record is, no data is there. So it return null, null not equal to null, condition false, it comes out the loop. Then we close the file, fclose of fp. Text wise binary mode. What is the difference between text and binary mode? So there are 3 difference between text and binary mode. One is storage of number. In text mode, one digit is required 1 byte of memory. In text mode, if you open the file, if you want to store a number, a digit is required, 1 digit is required 1 byte. In binary, as per data type, for integer data 2 bytes, float 4 bytes, double 8 bytes, character 1 bytes. If you want to store, for example, if you want to store 45,000, 45000, 45,000 in text mode, it will take 5 bytes because it's required a byte per digit. 45000, 45,000, 45000, totally 5 digits. So each digit is required 1 byte. So the total memory is required 5 bytes. If you open the file in text mode, if it is binary mode, it will take only 2 bytes because it is an integer. New line marking. New line marking, if the file open in text mode, the new line, to mark the new line, it take only 1 byte. New line means, that is if you enter a file line of data, so it occupies 5 bytes to indicate the new line. In binary mode, it occupies 2 bytes per line. For new line marking, if you enter 5 lines in a file, in text mode, it occupies 5 bytes to indicate 5 new lines. In binary, it occupies 10. So end of file marking. End of file marking, that is in text mode, end of file. Already we discussed, EOF is a macronym, that is it is equal to ASCII value 26. Based on the last character of a text file is 26. So this is a end of file marking. At the time of reach this character, it come out the file. That is, it is close the file. It is a end of marking to the text file. But in binary mode, it find the end of the file by using total number of character. If that file has 520 characters, so it count the character. If at the time of reaching 520th character, it come out the file. So it assume as end of the file. So based on total number of character, the 520, the total size of the file is 520 character. It read all character. After reading a 520th character, so it think it is the end of file. In text mode, it does not consider the total number of character. It considers the last character is 26. This is the end of the file. So end of file marking is differ. In text mode is ASCII value 26. Binary mode is based on total number of character. New line marking, 1 byte for text, 2 byte for binary. Because in binary mode we can store numerics, images and all things. The binary mode is suitable to store graphics. But text mode for only text, that is it treat all as text only. In text, we start from left. We write to start from left to right. If we want to write in a next line, if we want to write a text in next line, then we skip the line. Then we come to the beginning of the line. For example, if we want to write a line, just we start with left, then end in right side. Then we want to write a next line. Then we come to the beginning of next line. Beginning of next line, we start to write the text. In graphics, just we start the writing from left. Then we write to, that is we can write to right side. After that, we skip to the next line. Then we start to write. In binary mode. In graphics, just we start the first line, we start from left, then end with right side. Then we skip and come to the beginning in text. In binary, just we start right from left to right. Then we skip. We start we start to write the data from right side to left. Then we skip to new line. We start left to right. Then we skip the new line. Then start right to left. In binary mode, we start left. Then up to end, that is right side, we skip the line. Then we come to the beginning. We no need to come to the beginning of the line. Just we right to left. Then we skip left to right. Then right to right. That is in binary mode. It can write both direction. That is left to right and right to left. So we need a separate symbol for skip the line to come to the beginning of line. So it's occupied 2 bytes. In binary mode, we can write data from left to right and right to left, because in binary mode we can store graphics, numerics and all things. In text mode, we store only text data, text based data. In text based data, we must start left to right only. If we want to write another line, we must skip the new line and come to the beginning of the line. So it occupies only 1 byte. So no difference is not required. That is, we skip and come to the beginning in text mode. In binary mode, we can skip. We can write right to left if it is a graphics. If we want to, we also write text also in binary. We want to come to the beginning of the line. It has one indication. So 2 indication is available. One is skip the new line. That is go to new line for skipping. Then come to the beginning. So 2 bytes. So this is a two program, and this is one program to know the difference between text is binary mode. File star fp integer NOC. Through this program, this is a stud.txt is one of the file. That file is already stored in hard disk. It contains this data, that is RAM 85, 95, 90, Anil 75, 85, 80.00. This is the data of stud.txt. That file is already stored in hard disk, the same directory of this program file. Here we open that file stud.txt. This is also a typing error, because just here we put stud.txt. This one is here stud.txt. Here we put stud.txt, because we want to open this file. Just we copy this program from the previous slide. So display like that. We want to change poem.txt as stud.txt. stud.txt in read mode. So we open the file in read mode. Successfully open, the condition is false. It's start the loop. While of 1 ch equal to fgetc. We are also put getc. Both are same. Fgetc of fp. It read one character, that is r. It get r, then assign to ch. R equal to eof. The condition is false. So NOC executed. NOC, the default value of NOC is 0. Its increment by 1. Now the value of NOC is 1. The loop continue. It get another character a. The condition is false. It increment 2 m. It increment. So it's count all characters. RAM blank space 8 5 blank space. It's read character. It count it. Then it display the after reading all character up to 80.00. So after reading this 0, the last 0, the next character is end of file marking, ASCII value 26. So it read ASCII value 26. The condition is to break. So it come out loop. It display the NOC value. What is NOC? NOC is 32. Just we count RAM, because it is a text mode. It is a text mode. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. In text mode, 1 byte is required to store 1 digits. It does not follow the data type size. So 3, 4, 5, 6, 7, 8, 9, 10, 90.00 occupy 5 bytes. 9 0.00, 5 bytes. In similar way, it is also count. The next line marking, because it is a text mode, in next line marking, it occupies only 1 byte. So the total number of character is 32. It displays number of character equal to 32. So the count of character is 32, including new line marking 1 byte. Then it take 1 byte per digits. So 5 digits is required. We change this as binary mode, RB. We change, that is, it is not a poem.txt, it is stud.txt. Our file name is stud. So stud.txt, we put RB. So that file is open in binary mode. Then the same program, but we open in binary mode. What will be the output? Output is 31. How it is calculated? Because 90.00 treat as float. So it occupies only 4 bytes. Because in binary mode, the storage of number take as per the data type size. So 90.00 treat as float. So take only 4 bytes. But in in text mode, it occupies 5 bytes. Because each digit requires 1 byte. It is a 4 byte. Then this is also 4 bytes. In new line marking, it take 2 bytes. So it reduces 2 bytes. That is 30. In new line marking, text mode it take only 1 byte. In binary mode it take 2 bytes. So it reduces 2 bytes. Then increase 1 byte. Reduce 2 bytes 30. Increase 1 byte 31. It take 4 bytes. This take 4 bytes. It is 4 bytes. Blank space 5, 4, 5, 6, 7, 8, 9, 10, 11, 10, 11, 12, 13, 14. So the first line is 14. The next line is 15. 14, 15, 29. The new line mark. The new line mark is 2 bytes. 29 plus 2, 31.